Welcome back, everyone. In this video, we're going to talk about Docker, a powerful technology widely used in software development and deployment. Let's start with what is Docker. If you're a developer, tester, or operations engineer, understanding Docker can make your work much easier and more efficient. But before we jump into the details, let's first answer the big question. Why do we need Docker? Imagine you are a developer building a web application. You might be using Java with Spring Boot, Python with Django, or Node.js. These frameworks require specific libraries, dependencies, and configurations to function properly. On your local machine, you install all the required tools and everything works perfectly. You finish your work and hand over the application to the testing team. But when the testers try to run it on their system, they face errors. Maybe a required library version is different, or a particular dependency is missing. Perhaps the operating system behaves differently. This leads to the classic excuse, like it works on my machine. The real problem is that your machine and the tester's machine are not identical. Even small version differences can break the application. Now, let's assume the testing team fixes the issues and successfully runs the application. They approve it, and the software is ready for deployment on the production server. But when the operations team deploys it, another disaster strikes. It doesn't work on the production server. This happens because every system environment is different. The development, testing, and production environments all have slightly different configurations. These differences lead to unexpected bugs and failures. The limitations of virtual machines. To solve these mismatches, companies started using virtual machines, VMs. A VM allows you to create a completely independent system inside your computer. You install an operating system like Windows, Linux, or macOS. Then you install a hypervisor, such as VMware or VirtualBox, which allows you to create virtual machines. Each virtual machine has its own operating system, libraries, and dependencies. This sounds great. You can package everything inside a VM, send it to the testing team, and it should work exactly the same way. But there's a problem. VMs are very heavy. Each VM requires an entire operating system, consuming a lot of RAM, CPU, and storage. If you run multiple applications, each needs its own VM, making the system slow and inefficient. Another issue is cost. If you're using Windows VMs, you need to pay for a license for each instance. Even with Linux, managing multiple VMs takes up valuable system resources. This is where Docker and containers come in as a much better alternative. How does Docker solve this problem? Docker allows you to create containers, which are like lightweight VMs. But instead of running a full OS, they share the OS kernel with other containers. Here's how Docker works. You can install Docker on your computer. Inside Docker, you create a container with your application, dependencies, and required libraries. You share this container as a Docker image. Anyone, testers, developers, or deployment teams, can run this image and get an identical environment every time. With Docker, you don't have to worry about missing dependencies or OS compatibility. If the application works in a Docker container on your machine, it will work the same way everywhere. Now let's start with key benefits of Docker. Docker provides several advantages over traditional virtual machines. First, it is lightweight. Unlike VMs, containers don't need a full OS. They share the same OS kernel, making them much faster and more efficient. Second, Docker ensures consistency across development, testing, and production. Another major benefit is faster deployment. Since Docker packages everything together, applications can be deployed instantly. Containers also provide scalability, allowing applications to scale up efficiently. Lastly, Docker enhances portability. A Docker image can run on any system with Docker installed. How Docker works in real-life scenarios. Let's say you're building a Python web application using Flask. Instead of manually installing Python, Flask, and other dependencies on multiple machines, you create a Docker container. Now, when a tester or another developer needs to run the app, they don't need to install anything manually. They simply run the Docker container and it works instantly. Even in production, the operations team doesn't need to set up the environment manually. They just deploy the same Docker container, ensuring everything runs smoothly. This saves time and reduces the chances of human error during deployment. Docker ecosystem. What makes it powerful? Docker consists of different components that make it a complete ecosystem for managing containers. One of its most useful features is Docker Hub. Docker Hub is a public repository where you can find pre-built Docker images for popular frameworks like Node.js, Python, Factful, Redis, and etc. Instead of setting up everything manually, you can pull a ready-to-use image and start working immediately. Another critical part of Docker is Docker Engine, which allows you to create and run containers. Docker also follows a client-server architecture, making it easier to manage containers. There are two versions of Docker. First one is Community Edition, Moby, which is free and open source, and second one is Enterprise Edition, a paid version with additional features and support. Now let's discuss why you should learn Docker. Docker solves one of the biggest problems in software development, environment inconsistency. Ensures that your application runs the same way everywhere. Instead of dealing with dependency conflicts, developers can focus on coding. Testers and deployment teams can easily run the application inside containers. Testers and deployment teams can easily run the application inside containers. As a software company, we use Docker daily to build and deploy scalable applications. If you're looking for expert developers, we can help you build a robust containerized infrastructure. Our team specializes in modern, cloud-native solutions powered by Docker, Kubernetes, and DevOps practices. Let me know if you'd like a full series on Docker, where we explore commands, Docker Compose, Kubernetes, and real-world projects. I hope this video helped you understand what Docker is and why it's so important. Don't forget to like, comment, and subscribe for more tech content. See you in the next video.